Alright guys, we're going to look at a couple more examples. I want to change this example 3 though, and that's because I want to have one where we get a hole in the graph. We haven't really had that too much. So I'm going to make this, it's x squared minus 2x minus 3, and then over x squared minus 1, over x squared minus 1 again. Okay, so what I'm going to do first of all is I'm going to factor anything I can. So I'm going to have x minus 3 times x plus 1 over x minus 1 times x plus 1. All right, so now I can see that these two are the same. That's how we get a hole in the graph. Whatever's going to make that equal 0, and that's going to be negative 1. I plug that back into what's left, and I'm going to have negative 4 over negative 2. Negative 4 over negative 2 is 2. So that's where the hole in the graph is going to be. As far as the vertical asymptotes, since negative 1 canceled, that's not going to be a vertical asymptote, but this one will be. X equals positive 1. Horizontal asymptotes, I look at what I've got left. The degrees are the same, so I divide by these leading coefficients. It's going to be y equals 1. So now I've got my vertical asymptote here, my horizontal asymptote here. I've got a hole in the graph at negative 1, 2, so I just put like an open dot. All right, what about intercepts? Well, intercepts, I'm going to plug in 0 for y. So really, that's just whatever makes the numerator 0, and that's going to be 3. So I have an x-intercept at 3, 0. And I'm going to have a y-intercept. I'm going to set 0 in for x, and I get 3 for y. All right, so now I'm going to see if my function ever crosses the horizontal asymptote. So I'm going to set it equal to 1. You always want to do that. When I cross multiply, I get x minus 3 equals x minus 1. That's going to give me 0 equals 2, nothing to solve, so it does not cross. Okay, that's good news. That's always very helpful. The reason that's so helpful is because now I know if it doesn't cross, I don't have to check any more points. I can already see what's happening. This is going to have to go up like this. And since I know this point, I know it can't be up there if it's not going to cross. So we already have our graph. That's it. What about our domain and range? Well, our domain is going to be from, now watch this closely, it's going to actually go from negative infinity. I have a hole in the graph right there, so it's going to go from negative infinity to that hole. I didn't write that down. Oh, there it is. From negative infinity to negative 1, union, and then negative 1 to where that vertical asymptote is, 1, and then 1 to infinity. See, I can use any x except for negative 1 and positive 1. Those are not going to be x values we use. As far as the range goes, we're going from negative infinity up to 1, union, and it looks like it would be 1 to infinity, but it's going to be 1 up to that dot. I never use this y value of 2. There's a hole right there. So it's going to go union 1 to 2, union 2 to infinity. Okay? Let's take a look at this last one. So for this one, I look at my degrees. It's higher on top than on bottom by 1. That means I'm not going to have a slant asymptote. I'm sorry, I'm not going to have a horizontal asymptote. Instead, I'm going to have a slant asymptote. All right, so I like to start with the vertical asymptotes. That's going to be at x equals 1. All right, no horizontal. I'm going to find the slant now. And I can do that with either synthetic or long division. I just like to use long division. I feel like it just gives you the answer really quickly. Plus, it's just a good reminder on how to do it. X squared divided by x is x. X times x is x squared. X times negative 1 is negative 1x. Now I need to subtract, and I get 1x minus 3. 1x divided by x is 1, and now I can stop. This is it. My slant asymptote is y equals x plus 1. So I'm going to plot that. Just checking that slope. Okay, that's fine. Okay, let's find any x-intercepts. That's going to be whatever makes the numerator 0. So I'm going to have plus or minus radical 3 comma 0. Radical 3 is about 1.7. So I've got those 2 points. Those are really nice points to have. I'll explain that in a minute. Y-intercept, I'm going to plug in 0 for x, and I get 3 for y. And another good point to have. Now, sometimes you can actually cross the slant asymptote. I'm not going to make you check this, but just so you know how to do it, we would want to know, can our function equal the slant asymptote? So this is how I'd have to set it up. And then I'd cross multiply. Good. So now I can see I'm going to get 0 equals negative 2, so it does not cross the slant. And again, we're not going to have to do that this year, but next year in pre-calc you will. Okay, so it doesn't cross, and the reason that's so good to know is because if it's not going to cross this and it's not going to cross that, here's the way it's going to have to go then. It gets closer and closer to these asymptotes. Looks like that. And then here I've got this 1 point. I don't even have to find any more points. And I've got that. Okay, so there's the way the graph looks. As far as the way the domain looks, this domain is going to go from negative infinity to our vertical asymptote, which is going to be 1. And I said the only way to find the range is on the graphing calculator, but that was more for those other problems that we did from the previous part, like on this type. I can see that this is going way down low and then it keeps going up, and this is going way down low. So therefore the range on this one is actually going to be negative infinity to infinity. If you do a problem and you just want to check and make sure you did it right, you can always just put it in here. And it's going to graph everything. It's not going to graph the slant asymptote though, but there's everything else. It also doesn't graph the vertical asymptote. But that's the way it looks. Okay? Any questions?